Hi, this is acid and base neutralization part 2, and we are going to focus on writing acid and base neutralization chemical equation. Just a little bit of background about acids and bases and how they're relevant in your lives. One, brushing your teeth. The microorganisms in your mouth actually end up producing acid when you eat. And how we prevent tooth decay is that we have to brush our teeth. The toothpaste is basic and it helps neutralize the acid that's in your mouth after eating. Shampoo is acidic, so when you wash your hair with shampoo, it feels a little bit rough afterwards. The conditioner you put in afterwards is basic, and that ends up neutralizing the acidic shampoo, so that's why your hair feels nice and smooth afterwards. Some of us might experience heartburn if we eat certain foods. It causes extra production of acid in our stomach, and that kind of hurts. And what we can do is we can eat an antacid, and that's actually just a base, so something like Tums, and that's going to help neutralize the acid in your stomach, and that's going to get rid of that heartburn. A little bit of review from last time about acid and base neutralization. So some key things to remember. Last time I talked about how the amounts of acid and base have to be equal. This time we can get a little bit more technical with that. If you guys remember learning about moles. Moles is just a way of lumping molecules and atoms together, large quantities of atoms and molecules together. So it's kind of like a dozen. It's just a really, really big number, that's 602 hexillion. So same thing. If we have a certain number of moles of acid, like 4 moles of acid, you need to have the exact moles of base in order to neutralize it. So what I did here was to represent 4 moles, I used 4 hydrogen ions. Each of these represents a mole. And then I took 4 moles of hydroxide, and then that way they can neutralize each other. Keep in mind that water is created. We take the hydrogen from the acid and we're going to combine that with the hydroxide from the base, and that makes HOH, which is water. And that gives us a neutral solution of pH 7. Okay, so that's a review from before. So let's ask some questions. If I have 3 moles of a nitric acid, HNO3, how many moles of hydrogen ions will it produce? So if you look at the formula, there's one H. So it's a 1-to-1 ratio, meaning one nitric acid, one HNO3 will produce one hydrogen ion. So if I have 3 moles of HNO3, I should be able to produce 3 moles of hydrogen ions. And in order to neutralize the hydrogen ions, I need to have the exact same amount of hydroxide ions. So I'm going to need 3 moles of hydroxide ions to neutralize my 3 moles of hydrogen ions. So looking at 2, there are 15,000 molecules of lithium hydroxide. How many hydrogen ions does that lithium hydroxide produce? Well, that's actually a trick question. That's not an acid, so it produces no hydrogen ions. Well, how many hydroxide ions does it produce? So lithium hydroxide is a base, so it will produce hydroxide ions. It's a 1-to-1 ratio, so for every 1 lithium hydroxide, there's 1 hydroxide. So I have 15,000 molecules of lithium hydroxide. I'm going to make 15,000 molecules, 15,000 ions of OH minus. And that means I need the exact same number of hydrogen ions to neutralize that base. Okay? So let's look at writing those equations. I wrote out some steps for you, and then you'll see that each of these examples, I'm going to go after these 3 steps. Okay, so our first step, we're going to find the hydrogen ion on the acid and then the hydroxide ion from the base. Those two are going to combine to form water, so that's one of our products. The leftover anion from the acid will combine with the leftover cation from the base. That's going to make something called a salt. And salt is just a chemistry word for the ionic compound formed after an acid and base neutralization reaction. So we'll look at this. Okay. So in the future, you're going to get problems. You might get something like this. There's nothing on the right-hand side. That means you have to write a full, complete equation from here. So let's break down those steps. There it is again. Okay. First thing we need to do is to find the hydrogen from the acid. So this is going to be our acid. Acids usually have the H in the front. That's going to be our base. You can see that hydroxide right there. Okay, so what I've color-coded is purple would be the hydrogen from the acid. You can see I've color-coded it right there. Our OH from the base will be green, and so the anion from the acid will be pink, and then the cation from the base will be yellow. Okay, so here we have our reactants. They've been color-coded. So we're going to take the hydrogen and the hydroxide, and that's going to form water on the other side, HOH. You're going to take the metal, the cation from the base, and that's going to combine with the chloride, the anion from the acid. That's going to make your salt. This in case is sodium chloride. Okay, keep in mind, cations always go first. Na has a +1 charge, hydrogen has a +1 charge. Minus charge always goes second. All right, so let's take a look at the next one. Here we have nitric acid, HNO3, and lithium hydroxide. So that will be our base. There's that hydroxide. That's our acid. There's our hydrogen. So again, purple, hydrogen from the acid in front. What's left over is the anion. Yellow will tell us the cation from the base. The green is a hydroxide from the base. I'm going to take the hydrogen with the hydroxide. That gets put together to make water. That's going to be our product. I'm going to take the metal from the base, the cation from the base, and combine it with the anion from the acid, and that's going to make our salt right there. Cation first, anion second. Okay. So you'll notice the products for an acid-base neutralization reaction. You always get water. You always get an ionic compound. That's called a salt. Let's look at one more example. This one is a little bit more complex. So this is sulfuric acid H2SO4, and you have that lithium hydroxide again. So one thing I want to point out is that H2SO4 has 2 hydrogen ions it can give off. So that means we have to think about balancing our equation afterwards. So we'll break this down. This is our unbalanced equation. This one has to get written first. So there's my hydrogen ion from my acid. There's 2 of them. And there's my hydroxide ion from the base. Regardless of how many hydrogen ions your acid has, it will make water, HOH. That's it, okay? Don't worry about that too right now. Just know, hydrogen from your acid, hydroxide from the base makes HOH. That's your water. Then you're going to take your cation from your base, and then your anion from your acid, and that's going to make that salt. Okay, I wrote up the charges for lithium and sulfate so you can see why I put Li2SO4. All right, that's an unbalanced equation so far. Then you can write a balanced equation. You've got 2 hydrogens, so we need to put the 2 in front of there. That's going to double my hydroxide ions, and so that's why I needed 2 right in front of the LiOH. And you can also see that there's 2 lithiums there. That needs to be balanced by that 2 as well. All right, so that is it for writing acid and base neutralizations. Anytime you have questions, you can always join tutoring or ask. Bye-bye.